Okay, so taking a look at number 8, they want us to do the same thing as we did on 7. We want to write the explicit formula. So the sequence that they give us here, we have 3, -6, 12, -24, and 48. So we need to figure out what's happening between each term. So if you look, adding, if we add here, or we'd have to subtract 9, but then that's not going to work here. So think about multiplication. So for each one, we are multiplying by -2. So we are multiplying by -2. So when you are multiplying by a number, this is called a geometric sequence. So we have arithmetic and we have geometric. Okay, so we're going to look back at that formula sheet, and there is a geometric here, and we are looking at A sub n. S is going to stand for series or sum, so we're not doing that yet. So we're just looking at the top. A sub n equals A sub 1, and then they write it a little bit different than I normally write it. I normally write this R in parentheses and then make it n minus 1, but it really doesn't matter. Okay, just to talk about what this stuff means, A sub 1 is our first term, just like it was in arithmetic. R is called the ratio. So this is just what you're multiplying by. Now here's the thing, it has to be what you're multiplying by. If you're dividing by 2, you have to change it to multiplying by 1/2. So the ratio has to be what you're multiplying by. So then we're going to fill it in. So A sub n equals, our A sub 1 is our 3, our first term. Our ratio, we said we're multiplying by -2, so our ratio is -2. And then we want to keep the n, so n minus 1. And that right there is your explicit formula for this geometric sequence. Alright, so let's take a look at number 9. So for number 9, we're also writing an explicit formula for the nth term. We want to assume that it starts at 1. So -1, 1, -1, 1, Okay, so these are really just alternating signs here. But if you want to think about it as either adding or subtracting or multiplying or dividing. So adding or subtracting is not going to work here, but we are multiplying by -1 each time. So that means we're talking about a geometric sequence. So if we want to write an explicit formula, we can look at our formula sheet under geometric. So that's the one that says A sub n equals A sub 1 times R to the n minus 1. And we can fill it in. So A sub n equals A sub 1 is our first term. Well, our first term here is -1. R is what you're multiplying by. Well, we said that we're multiplying by -1 to the n minus 1. Now, there are other ways to write that. You could take out a 1. If you didn't want to use the formula, I want you to think about this formula. So you didn't always have to use this formula, but if you're given the formula and it's the same setup, I would just use it. But think about this. If I wrote this problem as -1 to the nth power, this does mean the same thing as this, but here's why. If I plug in 1 to get the first term, well, that'll give me -1. If I plug in 2, that'll give me +1. 3, -1. So this would also work. But if you don't want to have to come up with your own formula, I would use the formula they give you and then just plug in. Alright, so let's take a look at number 10. So 10, we want to write an explicit formula, and we're given 1, 1/4, 1/9, 1/16, 1/25. Now, if you try to look here, there is nothing that you can add or multiply by each term that's going to give us, okay? So this is not going to be arithmetic, and it's not going to be geometric, because there's no certain number that you can multiply or add to get from term to term. So what we're going to do, if you can't do that, we're going to look for a pattern. Okay, so because these are all written as fractions except the first one, I'm going to rewrite the first one as 1/1, just so I can kind of see what's happening there. And then what you want to think about is this is the first term, so this is when n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So when you're writing your formula, first off, they're all fractions. So that means that we're going to want to make our formula fraction. You notice they all have a 1 on top. Okay, no matter what, they have a 1 on top. So we're going to put the 1 on top here. So we really just have to worry about the denominators. So thinking about how do you get from 1 to 1 here, 2 to 4 here, from 3 to 9, 4 to 16. Hopefully you can see that if we were to square these n values, we would end up with the denominators. So this is just going to be formula 1 over n squared. And if you're ever unsure, just try it out. If I was to do a sub 3, which means I would plug in 3, that means my third term should be 1/9. Is that our third term? Yes. So that formula works. So always just try it if you're unsure if it's the right thing. Alright, 2 more. So for number 11 and 12, we are writing a recursive formula, which means you cannot use the formula sheet. And it means it has to depend on the previous term. Okay? So they actually are going to give us the explicit formula. Okay, so they give us the explicit, we have to come up with the recursive. So what I like to do for these is to actually just write out the sequence and then work from there. So if we were to write out, let's just write out like the first 4 terms. So I'm going to do a sub 1, which would be me 6, a sub 2, which would be me 9, a sub 3, 12, a sub 4, which would give me 15. So instead of having to work with this formula here, I can now work with just, this is the sequence that we need to work with. Okay, so this is the same thing as this. Alright, so what is happening from term to term to term? So we are adding 3 from term to term. Okay, so we are adding 3. So when you write your recursive formula, the first thing you do is you have to write the first term. Remember, if you don't know the previous term, you can't use recursive. So you got to always write out your first term. So we're going to write a sub 1 and a 6. And then we're going to have a formula for a sub n. So because we said we're adding 3, we're taking the previous term and we're adding 3 to it. So the previous term we can represent by a sub n minus 1. Remember, if that's a sub n minus 1 is the previous term. And then we are adding 3 every time to that previous term. So this would be considered my recursive formula. So let's just check. If the first term was 6, and we wanted to get the next term, we would do the previous term 6 plus 3, which gives you 9. Then the previous term 9 plus 3, which gives you 12. So that does work for the recursive. Alright, and then our last problem, we want to write another recursive formula. So it has to depend on the previous term. And they give us the explicit formula of -5 to the nth. So once again, I like to write out a couple terms. You can write out just 3 if that's fine with you. But so just plug in 1. Get -5. Plug in 2. Give us +25. Plug in 3. -125. And then I'll go ahead and do 4. Which will give us +625. So instead of having a formula, it's easier for me to see it if I have it written out as a sequence. So there's my first 4 terms of my sequence. So instead of writing an explicit formula, I'm going to write a recursive formula. So I need to figure out what's happening from term to term. So what we're doing here is we're actually multiplying by -5. Okay, so when you write a recursive formula, you always have to write the first term. So our a sub 1 is -5. And remember, you have to write the first term because it has to depend on the previous term. So then a sub n equals, so we're saying the previous term times -5. Well, the previous term we're going to write as a sub n minus 1. And then we're saying it's times -5. So that's how you're going to write it. If you'd rather write it where you have your -5 out front, this will also work. Probably see it more like this, but this means the same thing. So you're just taking your previous term and you're multiplying by -5, and that gives you your recursive formula.